Hello, Kevin from Yacht Engineering here, and today I will show you how to modify this Bitmain APW3++, so you can select the voltage output. This is a follow-up video to my L3++ undervolt video, and this APW33 is currently running at 8.7 volts, so I can run 2, or in this case 1.5 and minor L3 pluses with one supply at 8.7 volts. As you can see, both of the miners are running. Left one is half miner, right one is full miner. And we are pulling around 560 watts. And then we will go into the details of modifying the APW3++. I thought I'll begin this series with the plus model, because this is the most common power supply for the Antminers L3+. I will also do the APW3, the APW3 Plus, and the APW7, which is actually here. Okay. As you can see here, it is running. It is an APW3++. All right. So let's hop into the theory and then alter this power supply. Okay, we will need these things. We will need a multimeter, soldering wire, thick one, thin one, desoldering wire, flux, a soldering station, different trimmers, or actually we just need one trimmer, but I have a couple different ones here, and SMD resistors, or maybe just one resistor. And of course our APW3++. Okay. We will start by opening up our power supply. For this we have to open these 3 screws and these 3 screws. This one is already missing on this one. Be sure that the power supply is already plugged out of the grid for at least 30 minutes. Otherwise, it's possible you are shocked by still charged capacitors. Now we can open up the power supply and remove the plastic shroud. This is a good moment to clean the plastic shroud. Okay, now we can remove the PCB. The PCB is held with this, and this screws. So 5 screws. Be careful you don't touch the caps, because it's also possible these still hold voltage. For that, we're gonna go with our multimeter on DC voltage and check our voltage, which is really close to nothing. Okay. For safety, we will still try to short out the caps. Good. Now it's safe to work on this board. So we are searching for the feedback resistor of the voltage PWM voltage regulator for the output MOSFETs. These are the output MOSFETs, as you can see here. These are the MOSFETs. This is normally the voltage regulator. And now we're gonna search for the feedback pad. Okay, I now found the feedback resistor network of the PWM controller for the output transformer. And now I hooked up the desktop multimeter to the feedback pin. This feedback pin is held at 2.5 volts. And on the small desktop, on the small multimeter, I see the output voltage. As you can see here, I removed the feedback ground resistor and soldered two wires. These wires are hooked up to the multimeter and the resistor cascade. As you can see, this is high voltage running on this board, so do not do this at home. The easiest way to do this at home is to just exchange the resistor and assemble the power supply and plug it in then. Okay, as you can see now, we are getting around 12.06 volts output, and we dialed in a resistor of 5 kilo ohms, 5.1 kilo ohms. Okay, so we will increase this resistor till we get up like 8.7 volts output. For this, we just dial in a higher resistance. Okay, now I have 6.1 kilo ohms, and you can see the voltage is too big, and the controller will control the output PWM in that way till it reaches 2.5 volts again. And also the output voltage is decreasing. We let that sit now, and then we know how much voltage drop we get out of 1 kilo ohm. Okay, it sits now. We are at around 10.5 volts. So it's like 1 kilo ohm lowers the voltage by 1.5 volts. By the way, the maximum output voltage is 14.1 volts. After that, the maximum frequency is set. Okay, so we need to go down another 1.5, then we are at 9, hopefully. So we wait till this sits. Okay, now you can see this is not a fully linear thing, so best is to use a little bit of trial and error. Okay, we need to go even higher, but not too crazy. So I dial up by 100 steps. Okay, 8.9, a little bit lower, 8.8, 8.8. Okay, now we're getting somewhere. We are at 8.771. This is perfect. This is the perfect resistance to hit our 8.7 volts undervolt mod for the L3 Plus. Okay, sure, you can also set all different voltages with this mod as you like, but now we are just looking to put the voltage to 8.7 volts. Maybe I will create a sheet with the different resistances from 8.5 to 14 volts. So you exactly know which resistor you have to put to alter the voltage for whatever use you have for it. Okay, thanks. I will now exchange the resistor cascade to SMD resistor and assemble clean the power supply and assemble the power supply.
After some testing, I decided to exchange the SMD resistor to normal resistors and the trimmer so I can easily alter the voltage like plus or minus 1 volt. This makes the usage of the mod much easier. I also glued the trimmer with hot glue so it doesn't move. Okay, here is the list of the different resistances for different output voltages. Maybe your resistances may vary a little bit because of slightly different supplies, but all in all this should give you quite good values to start with. Okay, last point I wanted to touch is efficiency. So as you can see, here is the chart of the different efficiencies at different output currents. I did a few measurements and this graph looks quite promising, but I will do a special video with efficiencies of different power supplies in the future, but right now I don't have the proper measuring gear for performing a video that or performing measurements that really have high accuracy. In this video I did not mention too many details of where to put the resistor or how to combine resistors. This is because I don't want anybody with no electronic experience to work on these main power bricks. There will be one video on how to modify the hash boards of the L3 Plus so you can use standard 12 volt power bricks and still underwatch the L3 Pluses. Okay, that's it for this video. I hope you liked it. If you did, please leave a like. And if you want to see more of content like this in the future, be sure to subscribe to my channel.